Alright, so we've been talking about conic sections, particularly the parabola, and we were just writing it in standard form. Maybe I had a collection of points, maybe had the equation in general form, and then I had to work backwards and put it in standard form. But now we're going to graph the thing, okay? Sure, we've graphed parabolas before, but this is going to be another way to graph it. And if you look at this very strange picture, it's the same artist as it was before, another British artist on, I think this one's called Parabola. Anyway, do you see this little segment that's right in here? This is actually drawn correctly, like the person who made this knew a bit of math. Or maybe she found it on the website, I don't know. I'm going to assume that she knew a bit of math. Maybe she paid attention in high school mathematics. Okay, so it's that segment that's going to help us, and it's called the latus rectum. Okay, so the latus rectum of a parabola, it is a segment that passes through the focus. First of all, it's parallel to the directrix, and its endpoints are actually on the parabola. So if you look at the picture here, it is a segment that goes through the focus. It's going to be parallel to the directrix, and its endpoints are actually on the parabola. Okay, so we're going to see how that's going to help us graph this right here. Okay. Oh, did you see it pulsed? It pulsed. Latus rectum, of course that was pulsing. Find the length of the latus rectum if that's our equation. So it's very simple. It's centered at the origin, or its vertex is at the origin, and it just opens upwards. So it's a pretty simple one. Okay, so let's wrap our brains around this. This 4p that's right here, that means my focal length is equal to just p. Okay, so from 0 up to f, that's p. The coordinate here, that's just a p. Okay, so far? Since this is a horizontal line, it's parallel to this directrix. The latus rectum is horizontal because it's parallel to this horizontal directrix. Every single y-coordinate on there must be the same, right? Does that make sense? So whenever I write the coordinates for this point, Rocher, its coordinate has to be something, comma, p. Because everything that's on that latus rectum has to have a y-coordinate of p. Now, I don't know what the x-coordinate is, so I'm just going to call it x. Okay? So we're going to put that into the equation so we can find out like how long this thing is. Okay? So let's put this into the equation. X goes in for x, so it's just still x squared is equal to 4. We're trying to find the x coordinate here, right? We're trying to find the x coordinate here. 4p times my y coordinate. My y coordinate is p. So this simplifies to x squared is equal to 4p squared. And I take the square root, so it's equal to plus or minus 2p. Plus or minus 2p. This is what this is saying. The x coordinate for this latus rectum is plus 2p, so we're going to the right 2p, and minus 2p, so we go to the left 2p. It's 2p on either side. So that means its whole entire length is 2p plus another 2p is 4p. The latus rectum length is 4p. Hey, 4p, that's also in our equation. Look at that. It's right there in the equation. How strange. Anyway, so whenever I go to write the equation or have the equation, that number that's out in front of the y or the x, whatever it is, that's usually in parentheses there, that's the length of the latus rectum. So I can use that to help me graph like this. Okay, so its length is 4p. It's 2p to the right of the focus or 2p to the left of the focus. That's assuming it opens up and down. But if it opens right or to the left, it's still, well, here, let's just take a look. All right. So that 4p is the length of the lattice rectum. So the first thing that I'm going to do is I'm going to plot the vertex and the focus. I'm going to get the vertex from the h and the k from the picture. So there's that point. I'm going to get the focus from the p-value. The 4p, I just take the p-value, and on this one, since the h squared is going to open upwards, I'm just going to go up p from that. Okay. Now I'm going to plot the endpoints of the lattice rectum. I'm going to go to the right 2p, like so, and there's a dot, and then I'm going to go to the left 2p for another dot, and then I'm going to draw my parabola through those 3 points. Done. That's it. That's it. Okay, so if this opened in the other direction, opened left and right, a little picture here. If I had my focus and my vertex and my focus like this, if that's p, I'm going to go 2p up and 2p down. So that is not the right. Minus 2p this way and plus 2p that way. Up and down instead of left and right. Does that make sense? I'm glad that you think so. So let's put it all together right here. I have an equation of a parabola in general form. I'm going to graph it. I know that it's a parabola because I have just a y squared and no x squareds in there. Okay, so in order to get it into the proper form, I'm going to have to complete the square on that sucker. So I'm going to complete the square on the y's. So y squared minus 4y plus a blank is equal to, now let's get all the other stuff to the other side, minus 4x plus 4 plus another blank. So to complete the square here, I'm going to take half of that, so negative 2, square it, positive 4, add another 4 to that side, and let's do the algebra, clean this thing up. So y minus 2 squared is equal to 4x, add those together, plus 8. Factor out this negative 4 here. Y minus 2 squared is equal to negative 4 times x minus 2. Had to change the sign there because I really factored out a negative 4 from that. So putting all this together, I need a couple of points. I need a vertex point, first of all. So my vertex, switch these two because my x is with my x. So that's a positive 2, positive 2. Let's put that dot on here someplace. 2, 2. 2, 2. There we go. Okay, now I need my focus. In order to get my focus, I need a focal length. So negative 4 is equal to 4p. So my p is negative 1. Since this is a y squared, it's supposed to open to the right or to the left. It's negative, so it's going to open to the left. My focus is just 1 point to the left of that, and that is at 1, 2. My directrix, if I were going to plot it, is behind here a point. Okay, now I'm going to use that lattice rectum length, 4p. So this 4p, negative 4, actually. I'm going to divide that by 2 because I'm going to go 2 in one direction and 2 in the other direction. Divided by 2. I got to go up 2 to get 2 points. This is from the focus. And down 2 from the focus. And graph my parabola. Wonderful. I've got an idea. I've got a marvelous idea. Why don't you go back in time, rewind this a little bit, and why don't you look back at exercise 8 and try to graph that equation, and exercise 9 and try to graph that equation. Whoa, what happened to all the stuff? Oh, it's right there. Graph both of those two, and I'm going to put those graphs back on this slide. Just come back and check to see if you're graphing these things correctly. Okay, and that'll be it. That'll be it. All right, how'd you do? How'd you do? So what I did, of course, is I went back and I looked at the other one so I could put it into that standard form. Use the standard form so I can find all my little pieces, graph those little pieces. And I mean, we had already come up with the vertex, we had already come up with the focus and the directrix line. So the new part on this is the fact that 8 is the length of the lattice rectum. 4 to the right and 4 to the left of that focus point. And there's 3 points. That's enough to make our parabola. Okay, and on this one, our lattice rectum is 2. On number 9, the lattice rectum length is 2. So when I find my focus, tiny half, I go up 1 and I go down 1, and there are my 3 points to make my little parabola.
Is that a parabola?
Yes, 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 there is a parabola. Okay, so that polishes that off. We were able to define a parabola as a conic section. As you see in the picture right there, you take that double cone, that double napped cone, and you slice it, chop, with a plane that is parallel to one of the lateral sides there. That's parallel with that. And also as a locus. That locus, the definition was that it's a set of all points that are the same distance, equidistant from two things, the focus and the directrix. And we were able to find all of those different parts and stuff. We were able to come up with the equation of this thing in standard form and graph it in standard form. So here we go. We're going to be bouncing around whenever we do this assignment, because the first part of this is all, you know, a vertex is at the origin. So skip forward to the latter part of that chapter and do some of the tougher problems, because I know you can handle it. All right. See you in class, guys and girls.